welcome to this lesson on ionic compounds and polyatomic ions. So we talked about ionic compounds in the past where an ionic compound is a positive ion combining with a negative ion. And all the positive ions were metals and all the negative ions were non-metals, and they would bind together. And there'd be, one example like a potassium iodide. Potassium is the metal, iodine is the nonmetal. One's positive, potassium positive, iodine negative, and they bind together to form a compound. Now, in this particular lesson, you're going to learn how nonmetals, not many nonmetals, okay, they like to join and make molecules, as we've learned, okay, and nonmetals like to form molecules that have a negative charge. So they are called the most negatively charged polyatomic ions are listed below. The most common, I should say the most common. I should write that word in there, the most common, meant to say. Negatively charged polyatomic ions are listed below, okay? And there's a number of them. Nobody asks anybody to memorize these, not even, your grade 12 science students or even in university. Typically, are you required to memorize them? You do become very familiar with them if you do chemistry, and you learn them, and they kind of stay part of your memory. Now, the word poly means many, so this means many, right? Atoms. So many atoms, ions. So they are an atom that has a bunch of atoms together, polyatomic, and they form ions, which means they have a charge. And so here are some of the listed ones here that I'm going to put on the list, and you can look them up anytime. So you have nitrite, NO2, nitrate, NO3, both have a negative charge of 1. Hydroxide, a very common one. Hydroxide is very common. OH minus, which means it's -1. Hydrogen carbonate, which is another common one. It's in our blood. We have a fair bit of hydrogen carbonate in our blood. And it's a hydrogen, carbon, and 3 oxygens together. And it is a charge of -1. It's often referred to as bicarbonate as well. And just straight up carbonate, which is CO3, carbon, and 3 oxygens, makes for a -2. Sulfate, SO4, -2. And phosphate, which is PO4, and it has a charge of -3. So I've indicated the charge. This table should always be available to you, even if you were to write a test or an exam, you'd have it available to you because, these kinds of things are not things that typically students would memorize. Now, we can use these polyatomic ions to form ionic compounds or ionic bonds. So for example, let's say we were going to combine magnesium and sulfate. So we get sulfate from the chart right here, SO4 -2, and magnesium is +2. So magnesium +2, well, where did I get that from? I simply get that from my periodic table. So I look it up right there. Magnesium is +2. But you're not going to see sulfate on here because sulfate is already a conglomerate or a molecule of its own. So you have to look it up from this other table, okay? So that's why I provide this nice little neat table here that you're more than welcome to print off and keep handy at any time, all right? Okay, so we also have a way to do sort of our crossover method to produce the chemical formula for magnesium sulfate. So just like we did before, these kind of guys come over and they cross over, but the problem is here is that I have a +2 and a -2. Those charges cancel each other off. So it ends up just being one of each, okay? And I don't need to write it as 2 of each. So it ends up just being one magnesium. Well, gotta move my cursor into a better position. Here we go. So I just have to write one magnesium and one SO4, and the charges kind of cancel each other out. So there would be a +2, -2, but they just cancel each other. We don't write the charges, and it's done. So I just erase those charges, and that is my chemical formula for magnesium sulfate. And writing the name is even easier. Before we had to change the ending to "ide" and stuff. We didn't need, these are ionic compounds, so we don't need prefixes of di and bi and all that stuff, tri and tetra. They're not needed here, okay? Because these are ionic compounds, we don't use those prefixes. So this would just simply be written as magnesium sulfate. No requirement to write any "ide" in the end or anything. We just take the product of the polyatomic ion and put it at the end, and we do not change it to sulfide. If we were saying magnesium sulfide, we were implying that the sulfur was by itself. It was an ion of its own, and if we looked at that up, sulfide, it has a charge of -2, so it'd just be MgS, and there would be no SO4 if we were naming it that way. So it's very important that you leave the 8 on the end, because that sulfate tells us that this is SO4. Now let's try another one where we do have some numbers that change, like barium phosphate. Okay, so barium, if we look it up on the periodic table, is right down at the bottom here in the second column, and it's a +2. Okay, so it's way down here, +2, and that's what I've written it in as. And then I would get my phosphate from the chart up above. Phosphate came from here, right in here. So if I just kind of grab my highlighter right along this row, okay, there's where I'm getting it. That's where I get my chemical formula. There's where I get the name from. The charge is -3, which we've indicated here, okay? Now when we're doing it, we're going to do a crossover method again, but this time the numbers don't match up, so to cancel out, okay? So it's important that we, let's erase that highlighter there, that we now bring the 2 over here and the 3 comes here. So we're going to get barium, for some reason it still wants to jump on me, even though I do have my mouse in a pretty good place. The cursor, I'll move it back. Here we go. Barium 3 is coming here from the -3, brings it over. So that would in fact give us a total of +6. And then we need to have phosphates. We need to have a total of 2 of them. But because it's 2 phosphates, SO4s, we have to put brackets around it and then a 2 in here. Okay, and that's a really important step, that the brackets go in on any polyatomic ion once there's more than one of them. Okay, so that would be our chemical formula for barium phosphate. Okay, so this here is barium phosphate, and again, we don't have to put an "ide" or anything like that at the end. I know it can be sometimes confusing, some of the rules are tricky, but when we get into polyatomic ions, just nothing has to change. It's really that simple, okay? Now I can do one more thing here. I can say, how many of each atom do we have here? For example, I have 3 bariums, okay? I have how many phosphates? I have 2 phosphate atoms, right? And I have, or I shouldn't say phosphate, I should say gotta be careful here, phos for us. It's called phosphorus if it's just the atom. And then how many oxygens am I going to have? Well, this tells me I have 4, but I have 2 times 4. So 2 times 4 would be 8 oxygens. Okay, so 8 oxygen. So it's just an interesting way to look at it. When the bracket comes in, it doubles everything in the bracket. If you had a 3 there, it would triple it, and so forth, okay? Now, this is all part of some science I've hoped you've taken in the past, and so you may have learned a little bit about something called acids and bases. So I'm going to do just a really quick review of this that you should have known, and there are some really common acids and bases that you may have seen, and um, hydrochloric acid, HCl, sulfuric acid, H2SO4, acetic acid, which is a big long chemical formula of strange things that are appearing here for some reason. I wouldn't worry about it too much, but I didn't realize that. But for some reason, some of these are not being made small. So I'm just going to make them. These numbers should have been smaller. I'll try to make sure on your worksheet that I've done that so that you're not having to do that. And then nitric acid, which HNO3, carbonic acid, H2CO4, CO3, sorry, H2CO3, and then phosphoric acid, H3PO4. Those are all acids. And one of the things you'll notice is they all start with an H. They have a hydrogen that they're willing to give up. They're willing to get rid of, and that's what makes them acids. And then our bases over here are NaOH, sodium hydroxide. Magnesium hydroxide is magnesium OH2. Potassium hydroxide, KOH, and calcium hydroxide, which is CaOH2. And you'll notice that all the acids have a hydrogen to give up, and all the bases have an OH, which they can give up. And that's what defines them as acids or bases, okay? Acids give up hydrogen ions, and bases give up what are called hydroxyl. These ones, if we look it back up here, it's called a hydroxyl. I'm going to go back up to my chart here, or hydroxide, I should say, better pronunciation here. And sometimes they get called hydroxyls, but hydroxide, our bases give these guys up, okay? That's what they like to give up. So it's very common to see them in their chemical formula when we look at their chemical formula. And the neat thing about acids and bases is that maybe you know this, maybe you don't, but when you combine an acid with a base, the acid will give up a hydrogen and the base will give up a hydroxyl. And when you combine those two together, you actually get H2O. And it's a little bit a weird situation because you would think that this is then going to be considered an ionic bond, but the way hydrogen interacts with oxygen, it actually is not. It is a slightly different, but it's a fairly strong bond, especially for a bond where electrons are being shared, and that's really important because it makes water very stable in our society, in our world, where we live. And water is like really important. Nothing could live without water. It's one of the things they look for on other planets to determine if there's life, because they know that there'll be no life without water. So this is just an example question. I wanted to review this. This is technically part of the grade 9 curriculum, but a lot of kids, of course, would not remember this. I mean, why would you? You don't walk around the street thinking about acids and bases. But I wanted to throw these in here so that, if we see or come across some of these in your future chemistry courses, you shouldn't get too freaked out because, it's quite common that you'll see acids and bases and stuff, and you can kind of start to identify them. All right, so I've left you, I didn't leave any questions attached to this. I actually put the questions on a separate worksheet that I'm going to email you for this lesson. And part of the reason for that is that I like to reorient it to give you more space. So there's a sheet to practice doing a few polyatomic ions and creating the chemical formulas and naming them, which is really quite simple. And then there is also a sheet to do some review practice of naming and making chemical formulas for all kinds. So you'll have ionic compounds in there, you'll have molecular compounds in there, and you'll have polyatomic ions in there. So it's kind of a mixture, so it really brings everything together all in one place. I think it's time that you have a lesson where you do that, okay? So hopefully this lesson on polyatomic ions was useful, and you are ready to move on and do some more fun chemistry. All right, we'll see you next time.